Hey there, tech enthusiasts! Have you ever wondered what our world would look like if Nikola Tesla's most ambitious inventions had come to life? Nikola Tesla, one of the most brilliant minds of the 19th and 20th centuries, was truly a man ahead of his time. While his contributions to modern electricity and wireless communication changed the world, many of his groundbreaking inventions never saw the light of day. Imagine the possibilities. Today, we're diving deep into 6 of Tesla's most visionary inventions that never got built. Let's explore what could have been and what still might be. The Wardenclyffe Tower, Tesla's world wireless system. In France's picturesque Loire Valley stands Château de Brissac, also known as the Giant of the Loire. This imposing chateau, with its towering turrets and centuries of history, is one of France's most captivating castles. Beneath its beauty lies a chilling secret. Château de Brissac is haunted by the ghost of the Lady in Green. The Lady in Green is believed to be Charlotte de Brézé, the illegitimate daughter of King Charles VII, who met a tragic fate in the chateau. Married to Jacques de Brézé, she was killed along with her lover when Jacques discovered the affair. This violent act is thought to have bound Charlotte's spirit to the castle, where she is now seen as the Lady in Green. Charlotte's ghost is often described as a tall figure in a green dress with hollow eyes and a disfigured face. Her spirit is most frequently seen in the early morning hours, with her moans and whispers echoing through the chateau's grand halls. Some guests report seeing her near the tower rooms where she met her untimely end, a haunting reminder of her tragic death. Beyond sightings of the Lady in Green, Château de Brissac is known for other paranormal activity. Visitors experience sudden cold drafts, feelings of unease, and strange nighttime noises. Even the current residents, the Duke and Duchess of Brissac, have reported hearing footsteps and voices when alone. Despite its haunted reputation, Château de Brissac remains a beautiful piece of French history, attracting visitors worldwide. The serene beauty of the chateau, contrasted with the presence of the Lady in Green, adds to its allure. The Death Ray, Tesla's defense weapon. Tesla's Death Ray, officially known as Teleforce, is one of his most controversial and mysterious inventions. He envisioned it as a powerful beam weapon capable of destroying enemy aircraft, tanks, and ships from afar. Tesla believed the Death Ray could promote peace by deterring war, as mutual destruction would make large-scale conflict impossible. He hoped that fear of the weapon would lead countries to pursue peaceful negotiations. The concept involved accelerating tiny particles to incredibly high speeds using electrical force. When concentrated into a narrow beam, these particles would release an intense burst of energy capable of obliterating anything in its path. Tesla claimed the Death Ray could take down aircraft fleets from hundreds of miles away, sparking both intrigue and fear. Despite Tesla's assertions, the Death Ray was never built. He approached various governments, including the United States and Soviet Union, but none took his proposal seriously. Lack of funding and skepticism kept Tesla's vision from becoming reality. After his death in 1943, the US government reportedly confiscated some of Tesla's papers, leading to speculation about secret studies of his work. Today, high-energy particle physics has made directed energy weapons a possibility, showing that Tesla's ideas weren't entirely far-fetched. While his Death Ray never materialized, modern research into lasers and particle beams reflects his forward thinking. Tesla's Death Ray remains a testament to his imagination and complex view of technology as both a force for peace and a tool for immense destruction. The Earthquake Machine, Tesla's mechanical oscillator. Tesla's mechanical oscillator, often called the earthquake machine, was designed to harness mechanical resonance for energy generation or, at extreme levels, create powerful vibrations. This small steam-powered device vibrated at high frequencies, and Tesla believed that if matched to the natural frequency of a structure or even the Earth's crust, it could amplify vibrations to cause structural damage. In 1898, Tesla claimed the oscillator created such intense vibrations during an experiment that his New York laboratory began to shake violently. Panicking, he reportedly took a sledgehammer to stop the machine before it could bring the building down. While this story has taken on a dramatic flair, it illustrates the immense power Tesla believed his invention possessed. Tesla's intent with the oscillator was not destruction, but to harness mechanical resonance for practical energy applications. He envisioned oscillators that could generate significant energy from the Earth's natural vibrations, requiring minimal fuel. Though the device never moved beyond experimental stages, it remains a topic of fascination. Over time, the earthquake machine has been cited in conspiracy theories suggesting Tesla discovered a way to control seismic activity or unleash massive destruction. However, Tesla's work was more focused on understanding resonance principles than causing earthquakes. His earthquake machine has secured a place in popular culture as one of his most intriguing inventions. Although the oscillator didn't revolutionize energy production or cause real seismic events, Tesla's work laid the foundation for future research into mechanical resonance. The earthquake machine reflects Tesla's drive to push scientific boundaries, even with ideas that seemed extreme or far ahead of his time. The thought camera, Tesla's mind-reading machine. Tesla's fascination with the power of the human mind led him to propose one of his most imaginative inventions, the thought camera. In the late 1930s, Tesla claimed that he had developed a theory for a device that could project a person's thoughts onto a screen. He believed that through a combination of electrical signals and light, it would be possible to visually capture the images formed in the human brain. This idea stemmed from Tesla's deep interest in the connection between the mind and energy. Tesla envisioned that his thought camera could one day be used to record and display mental images, allowing others to see what someone else was thinking. He explained that every thought forms a particular image in the brain, which then creates a corresponding electrical signal. If these signals could be captured, Tesla theorized, they could be turned into visible images. In essence, this device would be a form of mind-reading technology, capable of turning abstract thought into something tangible. Despite Tesla's enthusiasm for the project, the thought camera never moved beyond theoretical discussions. The science and technology required to capture brain activity and convert it into images were far beyond what was possible in Tesla's time. However, the concept was remarkably forward-thinking. Today, brain-computer interface technology is exploring ways to connect the human brain with machines, with researchers making progress in translating neural activity into digital signals. In some cases, scientists have even been able to recreate rudimentary images based on brain scans, inching closer to Tesla's vision. Though Tesla's thought camera never became a reality, his ideas continue to influence modern neuroscience and technology. The field of brain-machine interfaces owes much to Tesla's early speculations, as researchers push the boundaries of how we interact with computers and how our brains can communicate with machines. Tesla's thought camera was a bold vision of a future where the human mind could be unlocked, giving others a window into our inner thoughts. Tesla's belief in the thought camera reflects his constant curiosity about the intersection of energy, technology, and the mind. While the device was never built, the questions it raised about human consciousness and the power of the brain continue to inspire researchers today, proving once again that Tesla's genius extended far beyond his own time. The flying machine, Tesla's electric airship. Long before airplanes, Nikola Tesla envisioned a revolutionary flying machine powered by electricity rather than propellers. His design resembled modern drones or vertical takeoff and landing aircraft, with Tesla believing it would be more efficient and faster than any other transportation of his time. Tesla's flying machine concept used electric propulsion, allowing it to hover, take off vertically, and travel long distances without needing a runway. Imagine the aircraft gliding silently, harnessing the Earth's electric field for power, and using electromagnetic forces to achieve great speeds without noise or pollution. Though he never built the machine, Tesla's ideas set the stage for future electric aircraft development. Today, electric propulsion is being explored for drones, personal aircraft, and even passenger planes to reduce emissions and noise. Inspired by Tesla's vision, companies like Tesla Motors are investigating electric propulsion for new transport modes, including electric vertical takeoff and landing vehicles. Tesla's dream of electric flying machines transforming transportation wasn't realized in his lifetime, but his concepts are now close to reality. Electric aircraft hold promise for revolutionizing travel, especially in urban areas where space for traditional airports is scarce. While Tesla's exact designs were never constructed, the principles he championed continue to shape aviation technology. His flying machine concept reflects his visionary approach, emphasizing efficiency, reduced pollution, and natural power sources. Tesla's forward-thinking vision remains a powerful source of inspiration for engineers and innovators striving for sustainable air travel. The weather control machine, Tesla's climate engineering vision. Tesla's imagination was boundless, and among his most speculative ideas was controlling the weather. He believed that by manipulating electrical forces in the atmosphere, humans could potentially regulate rainfall, prevent droughts, and even mitigate natural disasters like hurricanes. Tesla's weather control concept stemmed from his understanding of the interaction between Earth's electrical field and the atmosphere. Inspired by his work with high-voltage electricity, Tesla thought technology could be developed to create localized weather changes, like inducing rain in dry regions or diverting storms. He speculated that such technology could help stabilize the global climate and reduce damage from extreme weather events. Although Tesla's weather control machine was never built, his ideas anticipated modern discussions on geoengineering. Today, scientists are exploring climate engineering, including cloud seeding and solar radiation management, as ways to address climate change. Tesla's early interest in weather control foreshadowed these fields of inquiry. Though his specific weather machine never materialized, his work in atmospheric science and energy remains influential. Manipulating the weather is still a distant dream, yet Tesla's vision highlights his belief in technology's potential to solve humanity's biggest challenges. His idea for a weather control machine was a testament to his deep understanding of scientific advancement's potential and risks. Even now, Tesla's ideas about harnessing nature's power continue to inspire, reflecting his desire to use technology for the greater good and expanding the boundaries of possibility. And there you have it, 6 of Nikola Tesla's most brilliant inventions that never got built. Each one reflects Tesla's genius and his ability to think far beyond his time. It's fascinating to imagine how different our world might be if these ideas had come to fruition. If you enjoyed this exploration into Tesla's visionary mind, be sure to give this video a thumbs up, share it with your friends, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.
Have you ever gazed at the moon and wondered about the secrets it holds? From its role in shaping life on Earth to its stunning features visible even from millions of miles away, the moon is more than just a celestial companion. It's a world of wonder, with mysteries waiting to be unraveled. Are you ready to dive into 10 incredible things about the moon? Join us as we explore its fascinating facts, ancient impacts, and surprising characteristics. The moon was formed by a massive collision. One of the most fascinating aspects of the moon's origin is its dramatic creation story. Scientists believe the moon was formed around 4.5 billion years ago when a Mars-sized object named Theia collided with Earth. This cataclysmic event ejected a massive amount of debris into space, which eventually coalesced to form the moon. Evidence of this giant impact hypothesis lies in the moon's composition. Lunar rocks collected during the Apollo missions show a remarkable similarity to Earth's mantle, suggesting that both celestial bodies share a common origin. This finding has helped scientists piece together the violent history of our early solar system. The moon's formation played a pivotal role in Earth's evolution. The massive collision tilted Earth's axis, creating the seasons we experience today. Additionally, the moon's gravitational pull helped stabilize Earth's rotation, preventing chaotic wobbling that could have drastically altered our planet's climate. While we now have a clear idea of how the moon came to be, there are still ongoing studies aimed at understanding the finer details of its formation. Space missions and advanced simulations continue to shed light on the early years of Earth and the moon's shared history. The moon's birth story isn't just about its formation. It's a testament to the dynamic and often violent processes that shape the cosmos. Understanding this dramatic event helps us appreciate the interconnectedness of celestial bodies within our solar system. The moon influences life on Earth. The moon is more than a distant companion. It plays a critical role in shaping life on Earth. Its gravitational pull is the primary force behind ocean tides, creating the rhythmic rise and fall of water levels that have been vital to coastal ecosystems for billions of years. These tides, influenced by the moon's phases, help regulate marine life cycles. From coral spawning to the behavior of fish and other sea creatures, the moon's pull sets the pace for life in the ocean. Without the moon's steady influence, these ecosystems might not have developed as they have. The moon also impacts Earth's rotation. As the moon's gravity interacts with our planet, it slows Earth's spin by about 1.5 milliseconds per century. While this seems insignificant, it has a profound cumulative effect. Millions of years ago, a day on Earth was only about 18 hours long, but thanks to the moon, we now enjoy 24-hour days. The moon's presence in the night sky has also influenced human culture, from mythology and literature to calendars and rituals. Ancient civilizations carefully observed their phases to track time, plan agricultural activities, and guide navigation. The moon's impact on life extends far beyond tides. It's a silent but ever-present force that shapes our environment, culture, and daily rhythms. Without it, Earth as we know it would be an entirely different world. The moon has a far side, not a dark side. The far side of the moon has often been misnamed the dark side, but this is a common misconception. Both sides of the moon experience day and night cycles, just like Earth. The far side is simply the part of the moon that faces away from Earth due to tidal locking. Tidal locking means the moon rotates on its axis at the same rate that it orbits Earth, causing one side to always face us. This phenomenon is why we only see the familiar features of the near side, like the Sea of Tranquility and the Tycho crater, while the far side remains hidden from view. The far side of the moon was first glimpsed by humans in 1959, thanks to the Soviet Luna 3 spacecraft. This side has a rugged, heavily cratered surface, starkly different from the near side's smoother, darker plains. The lack of maria or lunar seas on the far side is attributed to differences in crust thickness and volcanic activity during the moon's early history. Exploration of the far side continues to provide valuable insights. In 2019, China's Chang'e 4 mission became the first spacecraft to land on the far side, uncovering data about its unique geology and deep craters that could hold clues to the solar system's formation. The mystery of the moon's far side captures the human imagination, reminding us of the unseen wonders that await exploration in our cosmic backyard. The moon is shrinking. The moon is slowly shrinking as its interior cools. This cooling process causes the moon's crust to contract, resulting in the formation of cliffs called lunar scarps. These scarps can rise as high as 300 feet and stretch for miles across the lunar surface. NASA's Lunar Reconnaissance Orbiter has captured images of these scarps, revealing that they are relatively young in geological terms, just a few 100 million years old. Some scarps even show evidence of ongoing activity, indicating that the moon is still geologically dynamic. This contraction has caused occasional moonquakes. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes occur due to the moon's shrinking crust and the gravitational pull of Earth. While they are not as intense as earthquakes, moonquakes can last much longer, sometimes up to 10 minutes. The shrinking moon also provides clues about its thermal evolution. Scientists study the size and distribution of scarps to understand how the moon's interior has cooled over billions of years, offering insights into the thermal histories of other rocky worlds. The shrinking process is a reminder that even celestial bodies we consider static and unchanging are constantly evolving. The moon continues to surprise us with its ongoing activity and the secrets it holds beneath its surface. Moon dust is surprisingly dangerous. The lunar surface is covered in a fine layer of dust known as regolith. While it may look harmless, this dust is surprisingly dangerous. Lunar regolith is composed of tiny, sharp particles created by billions of years of meteoroid impacts, which have pulverized the moon's surface. During the Apollo missions, astronauts discovered firsthand how problematic moon dust could be. It clung to their suits and equipment, and even got into the lunar module, causing respiratory irritation and damaging seals on spacesuits and machinery. The jagged edges of lunar dust particles make them abrasive, posing a significant challenge for future lunar missions. Prolonged exposure to these particles could harm both humans and equipment, necessitating innovative solutions for dust mitigation. Despite its dangers, lunar regolith has potential scientific and practical applications. It could be used as a building material for future lunar habitats or as a source of oxygen through chemical processing. Researchers are exploring ways to harness this abundant resource while mitigating its risks. Moon dust serves as a reminder of the challenges and opportunities that await humanity as we prepare to return to the moon. The moon is slowly drifting away from Earth. The moon isn't as stationary as it might seem. It's actually moving farther away from Earth at a rate of about 1.5 inches per year. This slow drift is caused by the gravitational interactions between Earth and the moon, specifically the transfer of angular momentum due to ocean tides. Tidal forces create a slight bulge in Earth's oceans, which exerts a gravitational pull on the Moon. This pull adds energy to the Moon's orbit, causing it to spiral outward over time. Though the change is gradual, it has profound implications for Earth and its future. As the Moon drifts away, its impact on Earth's tides diminishes. Over billions of years, this could lead to less dramatic tidal changes, which might significantly alter coastal ecosystems that rely on the Moon's gravitational pull. Additionally, the Moon's distance affects solar eclipses. A more distant Moon will appear smaller in the sky, eventually making total solar eclipses a thing of the past. This phenomenon also tells scientists about the Earth-Moon system's history. By studying lunar rocks and Earth's geological layers, researchers have pieced together how the Moon's gradual drift has influenced Earth's rotation and climate over millions of years. The Moon's drift reminds us that even the most familiar celestial bodies are not static. They are part of a dynamic and ever-changing universe with ripple effects that extend across space and time. The Moon has an atmosphere, but it's extremely thin. Contrary to popular belief, the Moon does have an atmosphere, but it's so thin and fragile that it's called an exosphere. This exosphere is composed of rarefied gases, including helium, neon, and argon, which are present in trace amounts compared to Earth's dense atmosphere. The Moon's exosphere is constantly being replenished by several processes. Solar wind particles, micrometeoroid impacts, and the slow release of gases from the lunar surface all contribute to this tenuous layer. Unlike Earth's atmosphere, the exosphere doesn't provide protection from radiation or support for breathable air. Because of its lack of a substantial atmosphere, the Moon experiences extreme temperature swings. Daytime temperatures can soar to 260 degrees Fahrenheit, while nighttime temperatures plummet to minus 280 degrees Fahrenheit. Without an atmospheric buffer, there's nothing to distribute heat evenly or shield the surface from direct solar radiation. This thin exosphere still holds valuable scientific insights. For instance, studying the Moon's exosphere can help scientists understand the behavior of gases on other airless celestial bodies, such as Mercury and certain moons of Jupiter and Saturn. The Moon's delicate exosphere highlights the challenges of future human exploration and settlement, as well as the ingenuity required to adapt to its harsh environment. The Moon experiences moonquakes. Just like Earth experiences earthquakes, the Moon has its own seismic activity, known as moonquakes. These quakes were first detected during the Apollo missions when astronauts left seismometers on the lunar surface. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes have different origins. Moonquakes can be triggered by the gravitational pull of Earth, meteorite impacts, thermal expansion from sunlight, or the Moon's internal cooling and contraction. Some of these quakes can last for an extended period up to 10 minutes because the Moon lacks the water-rich rocks found on Earth that help dampen seismic vibrations. There are 4 types of moonquakes: deep, shallow, thermal, and those caused by meteor impacts. Shallow moonquakes in particular can be quite powerful, reaching magnitudes of up to 5.5 on the Richter scale, enough to cause structural damage if humans were living on the Moon. Understanding moonquakes is essential for designing safe habitats for future lunar missions. Structures must be resilient enough to withstand these quakes and other environmental hazards. Moonquakes reveal that the Moon is not as geologically dead as we once believed. It's a reminder that even a seemingly barren world can have dynamic internal processes that are crucial for scientists to study. The Moon has water, but it's trapped in ice. The discovery of water on the Moon has been one of the most groundbreaking revelations of the 21st century. In 2009, NASA's Lunar Crater Observation and Sensing Satellite, LCROSS, mission confirmed the presence of water ice in permanently shadowed craters at the Moon's poles. These craters, located in regions that never receive sunlight, act as cold traps where temperatures can drop below minus 400 degrees Fahrenheit. At these frigid conditions, water molecules become frozen and remain preserved for potentially billions of years. This water ice holds immense significance for future lunar exploration. It could be used as a resource for drinking water, oxygen production, and even rocket fuel through the process of electrolysis. The ability to harness lunar water would make long-term habitation and deep space exploration more feasible. Scientists are also studying the origin of this water. It could have been delivered by comets and asteroids, or formed through chemical reactions between solar wind particles and the moon's surface. Understanding its origin provides insights into the history of water in our solar system. The moon's icy reserves symbolize untapped potential for human exploration and survival, paving the way for a new era of space travel and scientific discovery. The moon might hold clues about Earth's early history. The moon is often referred to as a time capsule for Earth's early history. Because it lacks weather, tectonic activity, and a thick atmosphere, its surface has preserved ancient features and records that have been erased from Earth over billions of years. Lunar rocks and soil provide clues about the early solar system. By studying the moon's composition, scientists have learned about the bombardment of asteroids and comets that occurred during a period known as the Late Heavy Bombardment. This era shaped not only the moon but also Earth, potentially delivering water and organic compounds critical for life. The moon's surface also offers a record of solar activity. By examining isotopes in lunar rocks, researchers can reconstruct the history of the sun's radiation and its effects on the inner solar system. Additionally, the moon's relatively unchanged crust holds information about Earth's early crust and mantle. Comparing the two bodies helps scientists understand how the Earth-Moon system has evolved over time, including the dynamics of Earth's magnetic field and plate tectonics. The moon's preserved history acts as a window into our past, reminding us that studying our closest neighbor can uncover secrets about the origins of our planet and the conditions that made life possible. The moon is a celestial treasure trove of mysteries and wonders, each fact revealing a deeper connection between our planet and its natural satellite. From its drifting orbit to the water hidden within its craters, the moon is far more complex and fascinating than it first appears. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the universe's wonders with us.
What if time isn't a straight line but something more flexible? Something that under the right conditions could fold, twist, or even repeat? Scientists have explored this idea through Einstein's relativity, quantum mechanics, and theories of closed time-like curves. Some believe time loops are purely fiction. Others think they could be hidden in the very fabric of reality. So let's dive deep into the theories, paradoxes, and real-world experiments that just might prove that time loops aren't just Hollywood magic, they could be real. Time loops. Imagine waking up to the same morning over and over again, every action you take, every word you speak, every choice you make, resetting like a broken record. Sounds like science fiction, right? But what if I told you some of the brightest minds in physics have seriously considered the possibility that time itself might not always flow in a straight line? Instead, it could loop, bend, or even fold back on itself, trapping events in an endless cycle. We've all seen movies and shows where characters get stuck in a time loop, repeating the same day, trying to break free, or using their knowledge of past loops to their advantage. But is this just a Hollywood fantasy, or could the fabric of time actually allow for such strange phenomena? Could time loops be real? Could you, in some bizarre twist of physics, find yourself reliving the same moment indefinitely? The idea of time loops isn't just some wild storytelling device. It has roots in deep scientific theories, some of which suggest that under the right conditions, time might not be as linear as we assume. From Einstein's relativity equations to the mind-bending possibilities of quantum mechanics, certain interpretations suggest that time loops might not be entirely impossible. In fact, some theories imply they could already be happening, hidden from our everyday experience. But before we dive into the theories and research, let's break down what a time loop actually is. Is it a glitch in the universe, a natural occurrence, or just a human illusion? Let's find out. Gödel's rotating universe. What if I told you that, mathematically speaking, time travel might already be possible, at least on paper? In 1949, the legendary mathematician Kurt Gödel proposed something that could rewrite everything we think we know about time. He wasn't just any mathematician, this was the same genius behind Gödel's incompleteness theorems, which shook the foundations of mathematics itself. And when he turned his attention to Einstein's general theory of relativity, what he found was nothing short of mind-blowing. Gödel discovered a solution to Einstein's equations that described a rotating universe, a cosmic dance where space and time weren't just linear, but could actually loop back on themselves. In this model, time wasn't a one-way street, it was a circular highway where, theoretically, you could travel along a certain path and end up in your own past. Yes, that means time loops could be a built-in feature of our universe, if Gödel's model were correct. So how does it work? Imagine the entire universe spinning like a giant whirlpool. As space twists, time gets caught in the motion, forming what physicists call closed time-like curves, CTCs, pathways where an object or person could move through space-time and arrive at an earlier point. This essentially creates a time loop, a scenario where past and future aren't strictly separated. But before you start making plans to visit ancient civilizations, there's a catch. Gödel's universe requires a very specific type of global rotation, one that doesn't match our observations of the real universe. Modern cosmology tells us that while the universe is expanding, there's no clear evidence that it's rotating in the way Gödel's equations describe. So does this mean time loops are impossible? Not necessarily. Gödel's work showed that time itself might be more flexible than we assume, opening the door for other theories that could one day prove that loops in time are more than just science fiction. Closed time-like curves. What if time wasn't a straight path but a loop? What if you could take a walk through space-time and, instead of moving forward into the future, you ended up back in your own past? Sounds crazy, right? But according to some interpretations of Einstein's theory of general relativity, this might not just be possible, it could be a fundamental feature of the universe. Enter closed time-like curves, a theoretical concept that allows time itself to twist and reconnect, forming loops that could trap events in an endless cycle. Imagine drawing a timeline on a piece of paper. Now, instead of keeping it straight, you bend it into a circle so the starting point eventually connects back to itself. That's a CTC, a space-time path where an object, or even a person, could travel and end up exactly where they started, but at an earlier point in time. This isn't just a thought experiment. Solutions to Einstein's field equations actually allow for CTCs under specific conditions. One of the most famous examples is Gödel's rotating universe, which showed that if the universe had a certain type of spin, time loops could naturally form. Other proposals, like wormholes and rotating black holes, also suggest that if space-time were bent the right way, closed time-like curves might emerge. But here's the big question. If CTCs exist, why don't we see time travelers popping up at random? That's where things get tricky. Some physicists argue that nature might have built-in safeguards to prevent time loops from forming freely. Stephen Hawking's chronology protection conjecture suggests that quantum effects could destroy any time loop before it fully forms, ensuring that paradoxes never occur. Still, the fact that CTCs are mathematically possible raises a profound question. If the universe can allow time loops, does that mean they exist somewhere out there, or are we just scratching the surface of something far bigger than we can comprehend? Novikov's self-consistency principle. Alright, let's say time travel is possible. You step into a time machine, travel back a few decades, and decide to change history. Maybe you want to stop a major event from happening, or classic time travel trope, you prevent your grandparents from meeting. Boom! You've just created a paradox, a contradiction that could break the very fabric of reality. But what if I told you that some physicists believe time itself wouldn't allow such paradoxes to exist? Enter the Novikov self-consistency principle, the ultimate rule book of time travel. Proposed by Russian physicist Igor Novikov in the 1980s, this principle suggests that if time loops exist, the universe has a built-in mechanism to prevent paradoxes. In other words, no matter what you try to change, history will self-correct so that the timeline remains consistent. It's like the universe is running an autocorrect feature for reality. Whatever you do in the past will always align with events that have already happened. Let's break it down. Imagine you travel back in time to prevent an invention from being created. According to Novikov, something will always interfere. Maybe you accidentally inspire the very invention you were trying to stop. The loop stays intact, and history unfolds exactly as it was meant to. The past is flexible only in ways that keep it logically consistent. This principle has huge implications. It suggests that time travelers aren't free agents. They can't just alter events on a whim. Instead, they become part of history, playing the role they were always destined to play. And here's the kicker. If time loops exist, they must already be playing out around us without causing contradictions. So could time loops be real? If they are, Novikov's principle suggests that we might never even notice. The universe might be a master of self-correction, ensuring that time remains an unbreakable, logical chain, No paradoxes, no rewrites, just one seamless, unchangeable loop. Chronology protection conjecture. Imagine a world where time travel is not only possible but common. People from the future randomly show up in the past, rewriting history, creating paradoxes, and leaving behind a tangled mess of cause and effect. Sounds chaotic, right? Well, according to Stephen Hawking, nature simply wouldn't allow such a disaster to unfold. His answer? The chronology protection conjecture, a theoretical safeguard built into the fabric of the universe to prevent time loops from ever forming. Hawking proposed this idea in 1992, suggesting that while Einstein's general relativity allows for solutions like closed time-like curves, CTCs, which could theoretically permit time travel, something in the laws of physics steps in to prevent them from becoming reality. Essentially, the universe acts like a self-policing system, making sure no one can break causality or rewrite history. But how does it work? One possibility is that the moment a time loop begins to form, quantum effects kick in and destroy it before it becomes stable. Some theories suggest that vacuum fluctuations, tiny, unpredictable quantum changes in spacetime, would build up to an infinite level near a time loop, ripping it apart before it can be used. Others believe that gravity itself could create an instability that prevents time travel from ever happening. So, if Hawking was right, this means that even if we discover a theoretical way to travel back in time, nature will always find a way to shut it down. No paradoxes, no rewriting history, no alternate realities, just one continuous, untouchable timeline. But here's the real question. What if the chronology protection conjecture isn't an absolute law, but just a tendency? Could there still be hidden loopholes, conditions where time loops might briefly exist before collapsing? If so, the universe might not be as rigid as we think, and the dream of traveling through time might not be entirely impossible. Experimental investigations. Alright, we've talked about theories, Gödel's rotating universe, closed time-like curves, and even Hawking's idea that time travel is off limits. But what about real-world experiments? Has anyone actually tried to prove that time loops could exist? The short answer? Yes. And some of the results are surprisingly intriguing. One of the most well-known names in this field is Dr. Ronald Mallet, a physicist who has spent decades working on a theoretical time machine. His idea? Using ring lasers to create a circulating beam of light strong enough to twist space-time itself. If space can be bent, and time is linked to space, then maybe, just maybe, a powerful enough laser could create a closed time-like curve, making time loops possible. While Mallet's work is still in the theoretical stage, it's one of the few serious attempts to explore time loops in the lab. But lasers aren't the only approach. Some physicists have looked at the quantum world for answers. In 2014, a study simulated photon-based time travel using quantum entanglement. Scientists at the University of Queensland managed to create a system where a photon, a particle of light, appeared to interact with a past version of itself, essentially behaving as if it were inside a time loop. While this wasn't real time travel, it hinted that nature might not completely forbid information from moving in strange loop-like ways. Then there's the research on black holes and wormholes. Some theories suggest that rotating black holes, like Kerr black holes, could naturally create conditions for time loops to exist. The challenge? We can't exactly step into a black hole and check. However, astronomers are constantly studying the effects of black holes on space-time, looking for signs that time behaves differently near their event horizons. So, what's the verdict? We don't have a working time loop yet, but experimental research is pushing the boundaries of what we know about time. Could future discoveries reveal that time loops are not only possible but already happening around us? Science isn't ruling it out just yet. Time loops in fiction versus reality. We've all seen it in movies. The protagonist wakes up, lives their day, something bizarre happens, and then boom! They're back at the start, trapped in a loop. Whether it's Groundhog Day, Edge of Tomorrow, or Tenet, time loops have become a storytelling goldmine. But here's the big question. How close is Hollywood's version to scientific reality? In fiction, time loops often work as a reset button, forcing characters to relive the same moment until they break the cycle, whether through self-improvement, solving a mystery, or fulfilling some cosmic purpose. But in real physics, time loops, if they exist, wouldn't necessarily follow a narrative arc. Instead of a magical force trapping someone until they learn their lesson, time loops in nature would be an inherent feature of space-time, a direct consequence of Einstein's equations, quantum mechanics, or even higher dimensional physics. So, could someone actually get stuck in a loop like in the movies? If closed time-like curves (CTCs) exist, it's theoretically possible that information or even conscious beings could experience cyclical time, constantly returning to the same point. But here's the catch. Novikov's self-consistency principle suggests that any action taken in a time loop must be consistent with history, meaning you wouldn't have free will to break out of it. And then there's Hawking's chronology protection conjecture, which suggests time loops should be physically impossible, nature's way of keeping history untouchable. That means no respawning, no rewinding, and no magical resets. So, while fiction lets us fantasize about infinite do-overs, reality is a bit more stubborn. Time loops may not follow Hollywood rules, but who knows? The universe still has plenty of secrets left to uncover. Maybe one day, science will reveal that fiction wasn't too far off after all. So, could time loops really exist? Or are they just a wild sci-fi fantasy? While science hasn't confirmed them yet, theories suggest they might be possible under extreme conditions. Maybe the universe is hiding its biggest secrets in the folds of time itself. What do you think? Are time loops real, or just a mathematical illusion? Let me know in the comments. And if you love exploring the mysteries of time and space, don't forget to subscribe to InnoVision Tech. Have you ever wondered just how far we can see into the universe? How far back in time can we peer to uncover the mysteries of the cosmos? The universe is vast, and every new discovery helps us understand it just a little bit more. But here's the big question. What if we could observe galaxies that formed just a few 100 million years after the Big Bang? Imagine what secrets they could reveal. Today, we're diving into the discovery of the most distant galaxy ever found and exploring how far we can actually see. Ready to join the cosmic journey? Let's go! Introduction to Cosmic Exploration. When we gaze up at the night sky, it's hard not to wonder about the vastness of the universe. How far does it really go? And what mysteries lie beyond the stars we see with the naked eye? These are the kinds of questions that drive astronomers and space enthusiasts alike to explore the cosmos. Over the centuries, our understanding of the universe has evolved significantly, thanks to groundbreaking technological advancements and the courage to venture into the unknown. In the early days of space exploration, the ability to view distant galaxies was limited by the tools available to astronomers. Telescopes allowed us to look deeper into space than ever before, but the farther we looked, the more we realized how much we were still missing. That all began to change with the advent of space telescopes like Hubble. Hubble gave us unprecedented views of the universe, showing us galaxies that were millions, even billions of light-years away. Yet even Hubble's extraordinary capabilities were still bound by the limits of the visible light spectrum. But what if we could see beyond visible light? What if we could look at the universe as it existed in its infancy just a few 100 million years after the Big Bang? With the launch of the James Webb Space Telescope, this possibility became a reality. Webb's infrared capabilities allow us to peer further into space and further back in time than any telescope before it. Thanks to Webb, astronomers have discovered a galaxy so distant that it has completely transformed our understanding of the early universe. But what exactly does this discovery mean? How far can we really see, and what can it tell us about the birth of galaxies? Let's dive into this groundbreaking exploration of the most distant galaxy ever discovered. The role of the James Webb Space Telescope. Imagine being able to see something no one else has ever seen before. That's exactly what the James Webb Space Telescope enables scientists to do. Launched on December 25, 2021, JWST has quickly become one of the most powerful and influential tools in the history of astronomy. Unlike the Hubble Space Telescope, which primarily observes invisible light, Webb is equipped to observe infrared light, a type of light that is invisible to the human eye. Infrared observations are crucial for studying distant objects in the universe because, as light travels across the vast expanse of space, it stretches out due to the expansion of the universe. This stretching causes light to shift to longer wavelengths, which we detect as infrared light. Essentially, the farther away a galaxy is, the more its light has been stretched, making it visible only in the infrared spectrum. That's where Webb comes in. Thanks to its cutting-edge instruments, the JWST is able to capture infrared light with an unprecedented level of detail. One of Webb's primary missions was to look deeper into the universe than ever before, and to study the very first galaxies that formed after the Big Bang. This is a critical task because understanding the birth and evolution of galaxies is key to understanding the origins of the universe itself. The JWST's ability to see through cosmic dust and gas allows it to provide a clearer picture of the earliest galaxies, which were previously invisible or difficult to study. By observing these galaxies, astronomers can unlock the secrets of how stars and galaxies came together in the early universe, offering new insights into the conditions that led to the creation of the cosmos as we know it. Webb's findings are already shaking up our understanding of the universe's evolution, and one discovery in particular has captured the attention of scientists and space enthusiasts around the world. But what exactly did they find? Let's take a closer look. Discovery of JADES GSZ 14-0. In May 2024, astronomers using the James Webb Space Telescope made a groundbreaking discovery that would change the way we view the universe. They identified a galaxy named JADES GSZ 14-0, located at a staggering redshift of 14.32. But what does that mean? Well, the redshift of a galaxy tells us how far away it is and how much its light has stretched as it traveled across space. A higher redshift indicates a galaxy that existed closer to the beginning of the universe, meaning JADES GSZ 14-0 is one of the most distant galaxies ever observed. At a distance of around 13.5 billion light-years from Earth, JADES GSZ 14-0 is located in a time just under 300 million years after the Big Bang. This is an incredibly important finding because it provides a glimpse into the earliest stages of the universe, when galaxies were first beginning to form and evolve. To put this into perspective, if we were looking at Earth from this distant galaxy, we would be seeing our planet as it was just a few million years after life began to emerge. The discovery of JADES GSZ 14-0 pushes the limits of what we thought was possible. It challenges the existing models of galaxy formation, suggesting that galaxies were able to form and evolve much faster than previously anticipated. The early universe was a chaotic place full of energy, gas, and radiation, yet somehow in this tumultuous environment, galaxies like JADES GSZ 14-0 were able to emerge. The fact that we can observe such an ancient galaxy is a testament to the power of modern technology, and it raises important questions about how galaxies formed in the first few hundred million years after the Big Bang. What does this mean for our understanding of the universe's infancy, and how much further can we see? These are just some of the exciting questions this discovery raises. Characteristics of JADES GSZ 14-0. When scientists first observed JADES GSZ 14-0, they were amazed by its size, brightness, and activity. Three characteristics that make this galaxy truly remarkable. Despite its extreme distance, JADES GSZ 14-0 appears to be quite luminous, meaning it emits an incredible amount of light for its age. This is particularly significant because galaxies in the early universe were expected to be much smaller and dimmer, especially in comparison to the massive mature galaxies we observe today. So, how is this galaxy so bright? The answer lies in the rapid rate of star formation within the galaxy. Spectroscopic data gathered by the JWST reveals that JADES GSZ 14-0 is actively producing stars, and this star formation process is likely responsible for its high luminosity. The fact that this galaxy is so active in its star formation so soon after the Big Bang challenges current models of how galaxies evolve. It suggests that galaxies in the early universe may have formed and matured much faster than we previously thought. Another fascinating characteristic of JADES GSZ 14-0 is its size. The galaxy spans over 1,600 light-years across, which is a significant size for a galaxy so young. This large size further challenges our understanding of how galaxies grow and evolve in the early stages of the universe. Astronomers expected early galaxies to be smaller and less structured, but JADES GSZ 14-0 bucks that trend. Its size and activity make it a valuable object of study for astronomers who are trying to piece together the story of galaxy formation. Additionally, the galaxy's composition is of great interest to researchers. Observations of JADES GSZ 14-0 have revealed the presence of key elements like hydrogen and oxygen, which are essential ingredients for star formation. These findings provide critical insights into the processes that fueled the creation of the first stars and galaxies. By studying galaxies like JADES GSZ 14-0, Astronomers are beginning to build a clearer picture of the early universe and how the first stars and galaxies came to be. It's discoveries like this that push the boundaries of human knowledge and open up new avenues for exploration. What more can we learn from galaxies like Jade's GSZ 14-0? The future of cosmic exploration looks incredibly exciting. Implications for cosmology. The discovery of Jade's GSZ 14-0 offers more than just a fascinating glimpse into a distant galaxy. It holds profound implications for our understanding of cosmology, the study of the universe's origins, structure, and evolution. As we peer deeper into the cosmos, we're not just uncovering more galaxies, but we're uncovering the very processes that shaped the universe in its infancy. Jade's GSZ 14-0, located a mere 300 million years after the Big Bang, provides critical insights into the early universe when stars and galaxies were first forming in the chaotic environment that followed the Big Bang. This discovery is crucial for understanding a period in the universe's history known as the Cosmic Dawn, the time when the first stars lit up the universe, pushing back the darkness of the cosmic dark ages. The light from these early stars helped to ionize hydrogen gas and set the stage for the formation of more complex structures like galaxies, black holes, and even planets. Jade's GSZ 14-0, with its high star formation rate and abundant luminous activity, serves as a cosmic time capsule from this pivotal moment in the universe's evolution. Moreover, this galaxy challenges our models of galaxy formation. Until now, scientists believed that galaxies in the early universe would be much smaller and less developed, but Jade's GSZ 14-0's surprising size and brightness suggests that galaxies might have formed much faster and more efficiently than we previously thought. This could alter our understanding of how galaxies evolve over time and may prompt astronomers to reconsider theories about the conditions required for galaxy formation in the early universe. As we continue to observe galaxies like Jade's GSZ 14-0, we may uncover even more surprises that will reshape the way we think about the birth and growth of galaxies across the cosmos. Future prospects. The discovery of Jade's GSZ 14-0 is just the beginning of an exciting new chapter in cosmic exploration. With the James Webb Space Telescope continuing its mission, astronomers are poised to uncover even more distant galaxies, pushing the boundaries of our knowledge further than ever before. While Jade's GSZ 14-0 holds the current record as the most distant galaxy ever observed, there's no telling how much farther we can look into the universe's past. The future of astronomy is incredibly bright thanks to the capabilities of Webb and other upcoming space missions. Webb's infrared instruments have allowed scientists to see galaxies from a time long before our solar system even existed. And these observations are not only helping us learn about the universe's origins, but also providing clues about its future. As we gather more data on galaxies like Jade's GSZ 14-0, we'll continue to refine our understanding of the universe's history, including the formation of stars, galaxies, and black holes. The implications of these discoveries go far beyond the early universe. They also hold the key to understanding how galaxies evolve over billions of years, which will help us predict the future of our own galaxy, the Milky Way. In the coming years, astronomers expect to discover even more galaxies that existed during the universe's early stages, revealing new secrets about the formation of cosmic structures and the evolution of the universe itself. As technology improves and our tools become even more advanced, the quest to understand the universe's earliest epochs will only accelerate. With each new discovery, we take one step closer to understanding how the universe came to be, how it evolved, and where it's headed in the future. The most distant galaxies are not just objects of fascination. They are keys to unlocking the mysteries of the cosmos, and the journey to uncover them is just beginning. Thanks for tuning in to InnoVision Tech. We've just scratched the surface of the universe's deepest mysteries, but there's so much more to discover. What do you think? How far do you believe we can see into space? Drop your thoughts in the comments below, and don't forget to hit that like button if you enjoyed this journey with us. Subscribe for more fascinating tech and space discoveries, and stay tuned for the next adventure. Until then, keep exploring the infinite possibilities.